Today, Lab will separate the iPhone 12 motherboard, demonstrating separation and recombination operation process. This video will give you a comprehensive analysis of the structure and repair difficulties. Lift the screen with suction cup. Disconnect the battery. Pry out the ear speaker flex cable, display flex cable, and touch flex cable. Disconnect other flex cables on the motherboard. Remove screws on the motherboard. Detach the motherboard and the Face ID module. The iPhone 12 in our hand is not US version, as its 5G network frequency band adopts the sub-6 GHz. There are primarily 3 antenna connection seats: upper antenna, NFC antenna, and lower antenna. By contrast, the US version iPhone will feature an extra M-Wave antenna, while the motherboard will have an additional M-Wave antenna connector seat. In addition to differences in outer look, the layout of the 3 motherboards is also different. The motherboard of iPhone 12 is placed on the left, while the motherboard of iPhone 11 and iPhone 11 Pro is placed on the right. As the new iPhone 12 lineup requires the baseband and chip of 5G to be added to the motherboard, Apple may need to redesign the motherboard and its layout. Next, let's take a look at the separation of the iPhone 12 double-stacked motherboard. Remove the foam on the motherboard with tweezers. Then take the sticker around the motherboard off. Heat the motherboard with hot air gun at 180 degrees Celsius. Remove the plastic part. Put the motherboard on the heating platform. Since the heating platform for iPhone 12 has not come out yet, we adopt the universal heating platform. Please notice that it requires 2 people to separate the motherboard here. Besides, since the middle layer of the iPhone 12 motherboard uses middle temperature tin soldering, which is different from the low temperature tin adopted in iPhone 11 Pro, the temperature of the heating platform needs to be adjusted to 200 degrees Celsius. When the temperature reaches 200 degrees Celsius, heat the edge of the motherboard with rotational air. Please be noted that excessive heating may lead to pseudo-soldering or falling off of parts. 2 rounds of vertical heating are advisable. Pry out the logic board. Remove the logic board and signal board. Attach the signal board to the PCB holder. Remove the thermal grease. To clean the tin on the bonding pad, smear rosin with soldering iron at 400 degrees Celsius and solder wick. The middle layer of the motherboard uses middle temperature tin soldering, which makes it harder to clean than the low temperature tin. Clean the bonding pad with PCB cleaner. Handle the logic board in the same way. As we mentioned in our previous video, the motherboard of the iPhone 12 and iPhone 12 Pro is almost identical in appearance, with the double-stacked soldering. The sole difference is that the connecting part of the LiDAR scanner on the iPhone 12 motherboard has no stuff. Beyond that, we can see 2 empty parts on the logic board after separation. The 2 parts are additionally reserved for the camera PMU2 and LiDAR PMU on the iPhone 12 Pro motherboard. The A14 chip nanometer process, which develops from the A13 chip, goes from 7 nanometers to 5 nanometers. As the first 5 nanometer chip in the industry, A14 Bionic is faster than every other smartphone chip, With A14 Bionic, the CPU, GPU, and machine learning abilities of iPhone 12 lineup have been improved substantially. According to Bloomberg, Apple is said to face shortages in power chips for iPhone 12. Power management is more important in the iPhone 12 than for its predecessors given additional camera features and 5G capabilities, increasing Apple's need for these parts. The SIM card slot of the iPhone 12 series adopts a standalone design, which is connected via flex cable. In case of any fault related to the card slot during repair, you only need to replace the standalone card slot. For comparison, the iPhone 11 card slot is also connected to the motherboard via flex cable, but it is embedded on the motherboard for iPhone 11 Pro series. The Lightning connector flex cable of iPhone 11 Pro integrates bot speaker IC, ARC vibrator IC, charging IC, and wireless charging IC, which increases the possibility of functional failure in the case of water damage or heavy fall. But these ICs are back on the iPhone 12 motherboard, which not only reduces the possibility of Lightning connector functional failure, but also makes it easier to repair in the case of water damage or heavy fall. Take the Face ID parts of iPhone 12 and iPhone 11 Pro to compare. In appearance, the iPhone 12 Face ID front camera module looks much the same as the previous iPhone 11 series, with some changes to the metal frame and flex cable. The layout of the infrared camera, front camera, and dot projector remains unchanged. It can be seen from the microscope and camera lens that the flood illuminator module at the ear speaker flex cable is different. The lighting area of the iPhone 12 flood illuminator is larger. Then we recombine the logic board and signal board. Attach the signal board to the reballing platform. Put the reballing stencil in position. Apply some middle temperature solder paste. Wipe residual solder paste with lint-free wiper. Heat the signal board with the heating platform at 200 degrees Celsius. After the solder ball is formed, turn the power off and cool the motherboard for 5 minutes. Apply some paste flux to the bonding pad evenly. Align the logic board with the signal board. Keep heating at 200 degrees Celsius after the alignment. Heat along the edge of the motherboard with hot air gun at 320 degrees Celsius. Let the motherboard cool for 5 minutes. Install the motherboard. Connect the flex cables and screen. Boot up and test. The phone turns on normally. The above is the separation of the iPhone 12 motherboard. Further, we use the 3D scanner app to experience the LiDAR scanner of iPhone 12 Pro. Now please feast your eyes on our working platform with the LiDAR scanner. Lab will continue to work harder. Please stay tuned. Thank you.